Alright, this is the Unit 12 test review for PreAP. Okay, so on the first ones we're just converting. So remember, if you're converting, you're going between the two forms. So if you start off with a radical, you should end up with an exponent, and if you start with an exponent, you should end up with a radical. Alright, so the rule here is when you have a power to a power, is that you multiply them. So that's actually m to the 12th. And then to convert that, again, it's the whole Kraken bottom. So m to the power of 12 over 5. And that's it. Alright, on the next one here, I noticed we're doing a cube root. Now, I also know that 64 is a perfect cube, and it's 4. So that gives me 2 times 4. And then to convert this, again, do the Kraken bottom, so x to the power of 5 over 3. And then y to the power of 6 over 3. So 2 times 4 is 8. I can't reduce the 5/3 anymore. I can reduce the 6 over 3 to 2, so that would be my final answer. Alright, this one here, notice you're doing a square root. So I know the square root of 4 is 2. I also know the square root of 81 is 9. And then again, if I do the Kraken bottom, then it's 2/9 times x to the power of 9 over 2. And that's my answer. Okay, so the rest of them are just converting also. Alright, down here is when we're actually going to start simplifying. So again, I'm looking at cube roots. I know that negative 64 is a perfect cube, so that's going to be negative 4. I also know that I can get 2 groups of 3 out of 6. I can get another 2 groups of 3 out of 7, but I will have 1 left over, so it'll stay on the inside. Okay, on 11, I have a power to a power, so I want to multiply. So I'm going to start with multiplying these two on the outside. So that gives me 1/4 times 4 over 3, which gives me 4/12, which is 1/3. Okay, so what I now have is I have 27 times x to the 12th raised to the power of 1/3. And then this will go to both of these. Now, I know that when I'm taking something to the power of 1/3, it's really a cube root. I know that 27 is a perfect cube, so that's 3. And then if I multiply these two, 12 times 1 is 12, divided by 3 is 4. So 3 times x to the 4th. Alright, on number 12, again, I have a power to a power, so I need to multiply all these. So here, if I multiply this, I get x to the power of, looks like 16 over 3, and then y to the power of 24. Here, I'm going to have x to the power of 1 and y to the power of 1, because 1/5 times 5 is just 1. Now, notice that everything is now the same. So I'm going to add my y's first, so I got 25. But notice here how this is 16 over 3, and this is 1 over 1. So remember, if I'm adding exponents, they have to have a common denominator. So what I'm actually going to do here is I'm going to change that 1 to 3 over 3, because that's still 1, and now I have my common denominators. So I would actually then have x, and that would be the power of 19 over 3. Alright, on this one here, first of all, I notice that it's a 1/2. There's a lot of different ways to look at this problem. I do notice I have a negative exponent. So when you have a negative exponent, remember, it flips and becomes positive. So this is now going to be on top. Okay, and I still have the 1 there. Okay, so here I have 1/49. I'm taking raising it to the power of half, which is a square root. So the square root of 1/49 is 1/7. And then I really can just multiply this, the power to a power, and that gives me x to the 3rd. Alright, on this one here, again, I have a negative exponent. So anytime I have a negative exponent, I flip it, and it becomes positive. Well, this is on the bottom. So I'm going to take it to the top and make it positive, which means on the bottom it's no longer there. And then I'm just going to start reducing. So I believe the greatest common, I think the thing they have in common here is 16. So that would be, actually I think it's even more, 32. So that would be 1/2. And then I have more x's on the top, and I have 5 more. And then all my y's move to the top, so 13. I'm going to get rid of the 1 here, so it's really x to the 5th times y to the 13th over 2. Okay, down here on these, I'm just starting to work them out. So on this one here, on number 15, I notice I have a square, excuse me, I have a square root here. So it has to be squared, which means that's squared. So that gives me x plus 12 equals x squared. Now, because I have an x squared, I need to make it equal 0 so I can factor and solve. So I'm going to move everything to the other side. So that gives me 0 equals x squared minus x minus 12. If I factor that, I get x minus 4, x plus 3, x equals 4, and x equals negative 3. Now remember, to check your answer here, you can put it in the calculator. So I'm going to go to y equals. And if I type in the square root of x plus 12, and here I just put an x. Alright. If I go to my table, I'm going to check both answers. Okay, so x equals 4. That one works because they're both the same. So this is an answer. Now I'm going to check negative 3. And you'll notice that these are opposites of each other. So negative 3 is the extraneous solution. Alright, on this one here, I need to add first. I'm going to add this 2 to the other side. And that gives me negative 1 times the cube root of 6 minus 2x equals 2. But then I got to divide by that. So now that gives me the cube root of 6 minus 2x equals negative 2. So I'm back to the negative 2. Now to get rid of a cube root, you cube it. So that gives me 6 minus 2x equals negative 8. Then minus 6 minus 6. Negative 2x equals negative 14. Divide by that. Running out of space. X equals 7. And again, you can check your answer, and it is an answer. Alright, on this one here, I'm not going to do it. I'm just going to kind of get you started, and you can figure it out from there. So you just square both sides to get rid of the square root. And then at this point here, y'all, you're just starting to solve it. So just solve for x. And I believe this one actually comes out to like x equals 7 or something like that. Alright, on number 18, again, we're just solving. So on 18, again, I need to get rid of the radical. So I'm going to square it. Whatever I do on one side, I'm going to do the other. So that gives me x plus 3 equals. Now remember, this is x plus 1 times x plus 1. And if I were to multiply all of that, I would get x squared plus 2x plus 1. And again, because I'm dealing with an x squared, I need to make the whole thing equal 0. So 0 equals x squared plus x minus 2. And if I factor, I get that, which means x equals negative 2 and x equals 1. Now, again, I'm going to check my answer. So if I come up here, I'm going to put that square root of x plus 3 on one side. And then down here is where I'm going to put the x plus 1. And I'm going to get x equals negative 2. Alright, so if I look at the negative 2, notice they're opposites. So this is my extraneous solution. And then if I look here at x equals 1, those are the same. So that's my real solution. Okay, on 19, again, I'm trying to get this by itself. So in order to get that by itself, I'm going to add the 3 over. So that gives me 2 times the cube root of x plus 3 equals negative 12. Then I'm going to divide. And that gives me the cube root of x plus 3 equals negative 6. And then if I cube it, because that's how you get rid of a cube root, that gives me x plus 3 equals negative 216. then minus 3. So on this one, x would equal negative 219. And again, you can check your answer. Okay, down here, I am just going to divide by the 5. So I'm going to divide by 5, divide by 5. That gives me x to the power of 3 over 2 equals 8. And to get rid of the power of 3 over 2, I flip it and raise it to the power of 2/3. Well, if I raise one side to that power, I need to raise the other side to that power. And if I put that in my calculator, it's actually right here. So if I raise that to that, and I get 4. So x equals 4. And again, you can check these answers too. All right. So if you look at number 24. Oh, let me point something out. Notice on 21 through 23, they all have an odd numerator. So remember that rule, like if it was 2/3 on top here, if it was 2/3 on top here, what I'd want to do is, I remember you'd have to do the whole plus or minus. So just be really careful about that. All right, let's take a look at 24. On 24, it says the time it takes for a pendulum to make a complete swing back and forth is given by that formula. A clockmaker wants to build a pendulum that takes 10 seconds to swing back and forth. That's quite a while. How long should the pendulum be? All right, well, t is my time, so 10 equals 4 pi times the square root of L divided by 64. Okay, so I need to solve for L so I can figure out how long. So I'm going to divide, and then divide, and I'm going to divide by that whole thing. So that gives me 10 divided by 4 pi equals the square root of L divided by 64. Well, I'm going to square that, which means I'm going to square that. So that gives me 10 over 4 pi squared equals L over 64, and then times 64, and then whatever I do on one side, do the other. So now I have 10 divided by 4 pi squared times 64, which will equal my length. So I'm going to put all of that in the calculator now. So 10 divided by, I'm going to do it this way. I'm going to do the alpha y equals. All right, so 10 divided by 4 pi times 64, and that gives you, I forgot to do something. Hold on. Alpha y equals 10 divided by 4 pi squared now times 64. And you get, I didn't do the parentheses. Let me do this again. Something's not right. All right, so I'm going to do 10 divided by 4 pi. And then I'm going to square that. And then I'm going to multiply it by 64. Oh, whoops. Oh my goodness, y'all. Hold on. This is like a calculator issue. So 10 divided by 4 pi. You get that. And then I'm going to square it. And then I'm going to multiply it. And that's what you get. 40.53. So here the length would be 40.53. And what are they measuring it in? Feet. Okay. So let's just look at the last one. This will be the last one that I do it for y'all, or with y'all. All right. So in this one here is a scale that classifies wind speed. Can be modeled by this function, where W is the speed of the wind. If B of W equals 12, what is the wind speed W in miles per hour? Well, here's B of W here, and here's B of W here. That's 12 equals 2.8 times the square root of W plus 6 minus 7.8. All right, so I'm going to add that to both sides. So that gives you 19.8 equals 2.8 times W plus 6. Then I'm going to divide by that. Alright, so I think I'm going to get a weird number here, but let me just double check. Yeah, so I'm going to get a strange number there. So I'm not going to quite do anything yet because I'm going to have to round it, and I don't want to mess up my rounding. So here I'll have 19.8 over 2.8 equals the square root of W plus 6. Well, I'm going to square that to get rid of it, which means I'm going to have to square that. And then once I square that, I'm left with this, which means I'm going to have to subtract 6 and then subtract 6. So in my calculator, here's what I'm going to put. I'm going to put 19.8 divided by 2.8 squared minus 6. Alright, so 19.8 divided by 2.8 squared. I'm going to put enter. And then I'm going to minus 6. And if I raise that to the, if I round that to the 10th place, W will equal 44.0 miles per hour. Alright, if you need any help with it, make sure you talk with your teacher, and good luck.